x is less than 0. What does that tell us? The second derivative is less than 0. What does that tell us about the function? It's concave down. Okay, that's going to be a part of your explanation. That's going to be part of what's going to help us figure this out. Between 5 and 8, we're concave down. Use the line tangent of the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. So I started to write the equation of the tangent line here. We're writing it at x equals 5. They told us that. So I got the y value of 5 from the table. So that's why I have y minus -2 or y plus 2. 3 is the slope. They gave that to us. F prime of 5 is 3. So that's where the 3 comes from. And x minus 5. And then I just moved the 2 over. So I subtracted it. All right, so it says to use the tangent line, and we're talking about where x equals 7. So I'm going to say the next part of my explanation is going to be the tangent line approximation for x equals 7 says y equals 3 times 7 minus 5 minus 2. So y equals 3 times 2 minus 2. So it equals 4. Okay, so the tangent line approximation for x equals 7 says that y equals 4. But it's saying that f of 7 has to be less than or equal to 4. That's where that other piece of information comes from. Okay, since f double prime of x is less than 0 on the interval from 5 to 8, okay, if our graph is concave down, the tangent line approximation is what? An overestimation. Okay, the tangent line approximation is overestimation. Is an overestimation. Therefore, f of 7 has to be less than or equal to 4. The tangent line approximation said that it was equal to 4, but that isn't, I can't spell therefore. I just want to leave the R out. Therefore, there we go. The tangent line approximation said that it was equal to 4, but that's an over approximation, so that's the maximum that it can possibly be. So since we know it's an overestimation, we know that it has to be less than, or it could possibly be equal to, but it's more likely that it is less than positive 4. Okay, so you get 1 point for the tangent line, and you get 1 point for that explanation. They explain it in a slightly different way, but essentially that's what it boils down to. Okay, so we're going to have a similar idea with the secant line here. It says use the secant line for the graph between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Okay, so the secant line is the line through those 2 points. So we are going to find the slope between 5 and 8. So 3 minus -2 over 8 minus 5 is our slope. So that's 5 over 3. So our equation here, let's write it at 5 again, like we did with the other one. So y minus the y value at 5 is equal to the slope times x minus the x value of 5. So y equals 5/3 times x minus 5 minus 2. So that is our secant line. You get 1 point for just writing the equation of the secant line. Okay. Now, when your curve is concave down, your tangent lines are over approximations. Me personally, if I'm trying to figure this out, I'm going to go over to the side and I'm going to draw a concave down increasing curve. And, well, it is increasing because we go from a negative y value to a positive y value. So we know that it's increasing, but the same could be applied if I did concave down and decreasing. But let's just go with increasing. So what the secant line does is it's connecting the two endpoints of our interval. So this is x equals 5, and this would be x equals 8 here. The secant line connects those 2 points. So where is the secant line in regards to the actual curve? It's under it. Okay, the secant line is under it. So if we plug in 7 into our secant line, I'm just going to phrase it the same way. The secant line approximation for x equals 7 is y is equal to 5/3 times 2 minus 2. So 10/3 minus 6/3. So that equals 4/3. Since f double prime of x is less than 0 on the interval from 5 to 8, the secant line is below the curve, is below f of x. Therefore, the y value f of 7 has to be greater than or equal to that approximation. That approximation of 4/3. The secant line is below the curve, so that would be the minimum that it could possibly be. It has to be above that value. Similar to how it has to be below the tangent line because the tangent line's an overestimation.